follows is an example of how to use the information from the previous videos on functions to apply to specific problem solving with functions. This particular problem describes a sector. This is a sector, which is a chunk of circle. It's essentially a bunch of pizza with a bunch of slices of pizza taken out. Now that sector can be as big or as small as I like. This angle, which is the Greek letter theta, represents the size of the sector. And if I make that angle bigger, then essentially the sector will be larger. What I can do is I can take that piece of circle and fold it so that this edge joins up with this edge and it forms a cone. Now when I look at the graph, I see the volume, the dependent variable, and I see that the angle of the sector is the independent variable. So from looking at that graph, I should infer that I can control the angle that I make the sector, and that's going to have a direct impact on the volume, that is the amount of stuff that the conical cup could hold. Now notice what I did before I started answering questions in this particular function, related to this particular function. I spent some time trying to understand what were the variables involved, how are those variables interrelated. I think it's important before you start answering questions related to functions that you understand what it is that you're studying. Now that I understand that a change in the angle that I make of the sector is going to have a direct impact on the volume, I can start answering related questions. First question is asking what is v of 180. That's how we read it. To answer the question mathematically, all we have to do is first identify 180 is substituted in a value for theta. So I find 180 on the theta axis, or in this case the horizontal or x-axis, and I follow up to the graph, and then I follow across to establish what value v of 180 is, which turns out to be, it looks to be about 225, and then I put the units down cubic centimeters. Now that's all you have to do to read a graph is you find one value and find the associated value that goes with it. But of course we also have to talk about it in context. So what this is saying is if I had a sector that was 180 degrees for the angle, that's basically a semicircle, and I folded that semicircle into a cone, that cone, according to these parameters, would hold 225 cubic centimeters. So to answer that question, I would write v of 180 is approximately equal to, I don't have the approximate sign, but it's approximately equal to 225 cubic centimeters. Um, yeah, cubic centimeters. And then I would describe that if a sector was formed using a 180-degree angle, then the cone formed would hold 225 cubic centimeters of whatever. So that gives you an example of first what is the value. My first statement determines the value of v of 180, and my second statement determines the meaning in context. The second question that was asked in this case is what sector angle will create a cone that holds the most liquid. That's basically looking at the graph holistically and determining what's the largest volume. And I can see the highest point on the graph up here corresponds to a volume that just barely exceeds 400 cubic centimeters. All I have to do then is follow directly from that point down to the x-axis, and I can see that there's going to be a sector angle somewhere between 270 and 315 degrees, probably closer to 290 degrees or so. So to answer that question, then I could say basically if a sector was produced that had a 290-degree angle, it would produce it would hold the largest, it would form a cone that would hold the largest volume. And then, you can use the notation like I did here and a statement in English to demonstrate your understanding. Solving an equation seems a little misleading because you might be looking for a function equation, but essentially this is an equation because it has an equal sign. And since the known value is the y value 300 and the unknown value is theta, the solution to the equation is values of theta that are going to produce volumes of 300 cubic centimeters. To answer that question, I need to find 300 cubic centimeters along the y-axis and follow that to the graph. Observe that the 300 value is crossed by a graph twice, as we produce two different angles from two different sectors, each of which is going to produce a cone that holds the same amount. Here what we're going to have is a cone that has a short height and a very wide base that will hold 300 cubic centimeters. And here we will have a cone that has a taller height but a narrower base but still holds 300 cubic centimeters. Finally, the last question, it says describe the domain and range of the function in context. Recall that the domain refers to possible values for the independent variable, and the range refers to possible values for the dependent variable. So when I look at the domain, I can simply observe that there is a graph as the angle theta goes from 0 to 360. You can see the graph zeroes out after that. It should make sense because the largest angle we can produce is a 360-degree angle, which would produce a circle, and rather than form a cone, it would just be a flat plate. Regardless, I would say that the domain is going to be defined by any number theta. I don't have the notation up. I should say less than or equal to, and there is a better symbol than that, theta, which would be less than or equal to 360 degrees. I just got some email. 360 degrees. So that would be the domain. Possible angles for the sector. For the range, I would say 0 because the smallest possible value for volume is 0, and then I can go up to the largest possible value for volume, which is around, it appears to be around 405 or so. So we could have volumes from 0, and they could range all the way up to, again, approximately 405 cubic centimeters. Hopefully this example, in conjunction with some of the notation and work in the previous videos, should help you understand that all the questions are essentially in the same narrative. If you're given a graph or an equation or a table, I'm going to use notation to answer and ask questions, and then I'm going to make sure that I can express my answers in context. The remainder of the problems from this homework set are posted on My Big Campus. My recommendation is make sure you try some of these problems on your own and answer them to the best of your ability. And if you have the time, run them by me and I can give you feedback to determine if you're on the right track.